Hi, we're starting Chapter 4 today, and we're actually going to do the first two sections as basically one lesson. The reason for that is in Section 4.1, and by the way, Chapter 4 is graphing linear equations and functions. That's the entirety of what the chapter is about. In Section 4.1, we're going to start with plotting points in a coordinate plane, which you can see up here. I think that's really a very it's a review of something that you've done for actually probably since 6th grade. Okay, plotting points. I'm going to quickly review that with you, and then we'll get into what we really want to move on to, which is actually how do we graph a linear equation in a coordinate plane. So to start off with review of plotting points in a coordinate plane, let's just go over a few basics that I would want you to know, and I think the things I'm going to be talking about here you will find are a review. When you have a coordinate plane, there's a few, again, vocabulary, I guess, that you should be aware of. We have an x-axis. You can see that they labeled it here. This is the x-axis. The x-axis is this one right here that goes horizontally from left to right on our screen. We also have a y-axis, and as you can see, this is the axis that is vertically from top to bottom across our paper. So we have an x and y axis. Anytime you have a coordinate plane, you have quadrants, and we have 4 quadrants. In the upper right-hand corner, this is quadrant 1. And in the upper left-hand corner, you have quadrant 2. And in the bottom left, you have quadrant 3. And in the bottom right, we have quadrant 4. We have 4 quadrants on any coordinate plane, okay? As far as plotting points, whenever you're plotting points, I always kind of equate this to battleship. A coordinate is always going to give you 2 numbers, and I know you've seen this before. Look, I'm going to make up something here. 5, -2. Now, 5 is your x-coordinate. The x-coordinate always comes first, and it tells you, I'm just going to put left or right, it tells you how to move left or right on your number line. The second part of this ordered pair, by the way, this whole thing is called an ordered pair. The second part of your ordered pair is called the y-coordinate. And the y-coordinate tells you what to do as far as moving up or down on this graph. So when you have 5, -2, I'll do this in blue. 5, -2 is indicating start at the origin. That's another vocabulary word I should mention. This is the origin. This point, 0, 0, is the origin. I guess I should get off this dot there. We don't have to put that there. The origin, 0, 0. When you want to go to the point 5, 2, you start at the origin and you go 5 right, 2 down. That is the point 5, -2. I hope I spoke that properly. I'm graphing the point 5, -2. 5 right, 2 down. If I was asked to graph the point, I'll do a different color. I was asked to graph the point, we'll say -3, 8. That means start at the origin and go 3 left, 8 up, and graph my point. So there's the point, -3, 8. Let me pick a different color. I'll pick yellow. Let's say that I labeled this point here, and I called that point A. And I asked you, what is point A? Well, to get to point A, we'd have to go 2 left, 7 down. I would call that point -2, -7. Okay, that's what Section 1 is about. They're going to ask you in Section 1 to give coordinates of points, to plot points in a coordinate plane, and describe the location of the point. Like this point here is in quadrant 4. The point in green that I graphed is in quadrant 2. The point in yellow, point A, that was in quadrant 3. Let me do one more. I'm just going to pick red. Not that this is wrong. I just wanted a different color. Let's say I had us graph the point negative 7, 0. Negative 7, 0. Well, that would be over here. If I asked you the location, okay, the location of this point would be on the x-axis. It's not in either quadrant. It's just on the x-axis. That would be the location. So that's what Section 1's about. I gave you a few questions in Section 1 only just to give you a little re-practice on that. So we're going to move on to the bulk of what I want to cover, and that's in Section 5.2 and 4.2, and 4.2 is graphing linear equations. Now there's two major things that we're going to have to do today regarding Section 4.2. And the first one, obviously, is build a graph and equation. So here's how we do that. To graph a linear equation, first of all, solve the equation for y. And I'm going to put if necessary down for that. Okay, sometimes they're already solved for y. This is what we did back in Section 3.8, solving equations, making sure that y is a function of x, solving for y. So that's the first step of graphing a linear equation. Make sure the equation's solved for y. I'll show you why that's really important in a minute. Secondly, make a table. And I wrote if necessary in there, and it covered this up. Let me just erase that. Make an XY table is what I wanted you to do. I'll just write down over here if necessary again. Okay. The third step after making the table is find 3 ordered pairs for your table. I always say to find 3 because if you find 3, it will show you if you've made a mistake. If you only find 2, you won't know if you have it right or not. If you find 3, you'll verify that you have it correct. So always at least get 3 ordered pairs, at least. Step 4, graph these 3 pairs on your graph paper. And then step 5, take your ruler, draw a line through those points, and be sure to put arrows at each end. And I guess for that, I better quantify that again if necessary, because normally that's the case, but there are certain problems where we would not put arrows at the end, but I'll show you when that happens. But typically, if it's just a generic, here's an equation, graph it, you're going to have arrows at the end. The second major thing we're going to do, I would call what we did here, this is the major thing. These are the major topic of what we are doing in Section 4.2. This other topic is a minor one, but one that we have to know also. You're also going to need to know how to check whether an ordered pair is a solution to an equation. I'll actually do this first because this is very simple and short, and then we'll talk about the graphing. So let's talk about how do you know if an ordered pair is a solution. This is actually very simple. Go to problem 3 on page number, we can move ahead to page number 219. Tell whether the ordered pair is a solution. They give you this equation, 2y plus x equals 4, and I want to determine is negative 2, 3 a solution. Well, this is very simple to do. You've actually done this earlier in the year, but just with one variable, not 2. All we have to do is the following. Take 3 and plug it in for y. Remember, when we have an ordered pair, ordered pairs mean, let me turn my layer on, ordered pairs mean x, y. So y is a 3. Take 3 and plug it in for y, take negative 2 and plug it in for x, and ask yourself, if you plug those in, is 2 times 3 plus negative 2 equal to 4? Is that true? Yes, it is. So negative 2, 3 is a solution. Okay, here would be a common error I've seen people make. They see negative 2, 3 in an ordered pair, negative 2 on the left, 3 on the right, and all they do is they go up here and they put negative 2 in on the left and 3 on the right. That is flat out wrong because think about it. What is negative 2? Negative 2 is the x value of the ordered pair, and 3 is the y value. You must plug in -2 into the x value. As you notice here in my error, if I do this, I plugged in -2 for the y value. This is a very common mistake I see people make. They just see -3 on the left, -2 on the left, I meant to say, 3 on the right, and so they go to the equation and they put -2 on the left, 3 on the right. The problem is the -2 actually belongs there. It's x, and the 3 actually belongs here. It's y. You got to get them plugged in the right places. So that's how you can find if an ordered pair is a solution. I think that's pretty easy. So I won't spend more time on those. You see on questions 3 to 8 in the bookwork, they will ask you to do that. Okay? Let's talk about graphing equations. I'm going to go ahead and move to number 16. I will provide you with graph paper like this tomorrow, so you will have it easy. You won't actually have to draw all this out. So, to graph an equation, let me go back to my steps. The first step of graphing an equation is solve the equation for y if necessary. I'm going to show you why that's super important. It's going to make a problem like this simple. So let's solve this equation for y first. So to do that, we got to get rid of the plus 4x first. Remember, let's just review that portion real quick. I have a times 3 I got to get rid of and a plus 4x. Remember, we're doing inverse operations. I got to get rid of that plus 4x first, so I'll subtract 4x from each side. This work should look familiar to you. And when you do that, you get 3y on the left, and you have 12 minus 4x on the right. Obviously, we can't subtract those. They're not alike. And then from there, to get y by itself, I got to divide by 3. And on the left, I get y. Now, on the right, remember, we did this earlier back in Chapter 2. When we have a fraction and there is 2 terms in the numerator, we can break this up into separate fractions. We should actually do that. So we have 12 thirds minus 4 thirds x, and I can simplify 12 thirds. 12 thirds is plain old 4 minus 4 thirds x. Okay, so I have solved the equation now for y. And that's going to make it easy for me to make a table. So I'm going to make a table now. And let's go through how I got these points. Very simple. I can pick any values I want. So I'm going to start off by picking 0. And I picked 0 for a reason. That's always easy to plug in. In fact, I would always recommend, if possible, using 0. Let's try that. If I plug in a 0 here, what's anything times 0? And I hope you're coming up with it's nothing. Well, 4 minus nothing is 4. Well, that was easy to figure out. Now, I picked this problem for a couple reasons, because the next things I need to talk about make clear to you. One reason I picked the problem is to solve for y. The second reason is, do you notice how we have a fraction here, thirds? Most of you don't like working with fractions. You may use your calculator on this, but most of you still don't like working with fractions. Since we have a third here, it is easiest for you to plug in numbers for x that are multiples of 3, like 0, 3, 6, 9, 12, 15, multiples of 3. If you plug in multiples of 3, it will make the fraction go away. So I decided to plug in 3. And then if I plug in a 3, 4 thirds times 3, you can use your calculator for that, is 4, and then you have 4 minus 4 is nothing. And then I plugged in 6. 4 thirds times 6 is 8, and 4 minus 8 is negative 4. Okay, I have 3 points for a table. All I got to do is plot those points. Let's plot them right now. Here's 0, 4. Remember, 0, 4 means this. It means no left or right up 4. 3, 0 means this. It means go 3 right, no up. And 6, negative 4 means go 6 right, 4 down. Now, take your ruler out, draw a line through this, make sure you put arrows at the end. Here's what this is showing me. Some people ask me, why do I have to graph? I don't want to, I don't like graphing. Well, they're actually graphing. There's a main reason why. Think about this for a minute. If I said to you, go home tonight and I want you to find all the solutions to this equation. Find every possible pair xy that will make this true? Do you know how long that would take you? I want you to think about that for a minute. If I asked you to just write on paper every xy pairing that would make this true, it would take you forever. You would never get done. There's infinitely many answers. It would be impossible for you to write them out. That's why we graph. A graph is a visual picture which shows, hey, any point on this line is a solution. The arrows tell me that this occurs forever. It goes on forever. That's why we graph. Graphing is actually the shortcut to getting this done. I know most of us don't like graphing. We consider it a pain. But graphing in this sense is great. It allows us to show all the answers where it would be impossible to write them all out. So that's why graphing is so important. Next page here. Okay. You're going to see questions like numbers 19 to 22. Graph these, and it's x equals 0, y equals 0, and so on. Okay? Whenever you have just an x equals equation without a y variable, it's a vertical line. I want to show you why that's the case. So I just made up something. Why is x equals 4 a vertical line? Well, first of all, let's make a table of x equals 4. Okay? There's only one value for x you can plug in here. It's 4. Right? So I can plug in 4. I can't plug in any other value that will make this true. But now for the y values, there is no y value listed. In other words, it doesn't matter what y is. X must be a 4, but y could be anything. There is no y value here. It doesn't matter what I plug in for y because there is no y value. As long as x is 4, this is true. Well, think about graphing these points now. If you graph each of those points, let me do it. I'll do it over here in blue. 4, negative 2, 4 right, 2 down is here. 4, 3 is here. 4, 5 is here. And 4, 4 is here. Well, look at what these points are doing. They're creating a vertical line. Okay? X equals 4 is just a vertical line. It's just all the points. Think about this. This line, any x value on this line is 4. Now, the y value changes, but the x value on this line is 4. If I pick this point down here, that's 4, negative 6. You notice the x value is always 4. That's why x equals 4 is a vertical line. Now, if you have a y equals equation with no x in it, like y equals negative 2, it's going to be horizontal. It's going to be a horizontal line across your paper. Let's see, why is that true? Well, I'll make a table again. Y must be negative 2. That's the only value I can plug in. But again, x could be anything now. It doesn't matter what I plug in for x. There is no x value in here. X could be anything for my table. Well, let me actually graph these. Here's negative 1, negative 2. Here's 0, negative 2. Here's 3, negative 2. Well, look what happens. I draw a line through it. It's a horizontal line, and it's at y equals negative 2. Even if I go over here, the point negative 8, negative 2 is on this line. This line, every y value must be a negative 2. The x values can change. The y values can't. That's why in the last two slides here, any x equals equation, which like in numbers 19 to 22, would just be a plain old vertical line. And any y equals equation that does not have an x value in it would just be a horizontal line. Okay? One thing that you'll see, and if you look back on page 216, you'll see they put it in highlighted form. This sort of equation is called standard form. Now, we've already worked on standard form earlier today in this problem here. Can you see in this problem, let me write it out maybe in yellow. Can you see, and let me make this bigger, can you see the form ax plus by equals c? Now remember, when you add, you can reverse the order. I have a number times x plus a number times y equals a constant. That's standard form. Number 16 was a standard form problem. Whenever you have standard form, it's best to solve. It's always best to solve for y first right now. Okay? That's the best thing to do right off the bat. Now, you can graph equations in standard form if it's an easy question, but it's best to solve for y, which is going to give you an equation. I'm going to talk about this in another video. If you solve the equation for y, you can also use your graphing calculator to help you generate a table, which is a great thing. I'm not going to be able to get to that in this video today, though. Okay? So this is standard form. I showed you we worked on that in 16. Okay? If an equation is in standard form, again, solve for y before graphing. That's just a general thing. Always solve for y before graphing on that. Like if we had 2x plus 5y equals 12, it would be best for me to say, okay, I'm going to quickly take away 2x from each side, which gives me 5y equals 12 minus 2x. And now I can divide each side by 5, and y would equal, I'm going to break this up into separate fractions, 12/5 minus 2/5 x. Okay? And again, the advantage of this is we will be able to plug that in our calculator. I just don't have time on today's video to go through that. I will do that, I think, for the next video. Okay? 26. Let's try 26. Now, if you look at 26, the directions are graph the function with the given domain, then identify the range. So I want to graph this. Well, I got some good news for you. Do you notice this problem? It's already solved for y. That makes this easy. Okay? In this problem, they told us the domain is x values greater than or equal to 0. That means when I make my table, maybe I should put a little note here. And I'll just star this right here above the x. Okay? Put a little star here, a little note. I can only use x values greater than or equal to 0. That's what this domain tells me, okay? I can only plug in x values 0 or greater. So I'm going to do that. Well, I'll plug in 0 first. That's super easy. 3 times 0 is 0. 0 minus 2 is negative 2. There's 1 point. Well, I'll plug in 2. 3 times 2 is 6. 6 minus 2, I meant to say, is 4. And then if I plug in 3, 3 times 3 is 9. 9 minus 2 is 7. Well, there's 3 points. I always told you if you graph 3 points, that's enough. Let's plot those 3 points. 0, negative 2 is here. 2, 4 is here. 3, 7 is here. Now, I want to draw a line. Now, this is one of those problems I'm not going to put an arrow at each end. Okay, and here's why. I can only graph x values greater than or equal to 0. So let me get out my red pen here. This is not wrong. I'm doing this so it shows up nice, okay? Think about my graph right now. I'm going to draw this little dotted line. X is greater than or equal to 0 starts right here. The x values that are greater than or equal to 0 start here and only go to the right. So my line cannot pass to the left of this because I only want x values that are to the right of 0. If I put line down here, I have x values less than 0. This would be a picture of a graph where the domain is x greater than or equal to 0. It's only going right. Okay, now the next thing they want me to do is write the range. And let me use a blue marker. Now, do you notice my range? Now, remember, my range would be showing my y values. So let me take this out and do my y values. Do you notice the lowest y value is here at y is equal to negative 2. And, let me say and, my graph only rises from there. Well, my range then is only, it's y greater than or equal to negative 2. Can you see that in my picture? The lowest y value is at negative 2, and this graph just keeps on going up, as you can tell here, forever. So my domain in this graph is labeled in red. My x value is only greater than or equal to 0. My range is all y values that are greater than or equal to negative 2. You can even see it on my table. You notice on my table here, I should have done that in blue. Let me just erase that. You notice on my table, my lowest y value is negative 2, and from that point on, they just continue to rise. Okay, so there we've answered 26. We graphed it. We graphed it with this domain and range. Obviously, what I wrote here in red and blue, these little lines were just so we could see. That wasn't part of the answer. Okay, that was just for me talking and you could see. But there's my graph, there's my domain, there's my range. Okay. Let's do one last problem. I'm going to give you a worksheet tomorrow, and we would have to do this for story problems. It says, answer each problem, put the graphs on graph paper. Be sure to use an appropriate domain and range for each problem. So we've got to make sure we think about that as we do it. It says, suppose that Roger hikes at a rate of 3 miles per hour. Write an equation to find the miles hiked after X hours. So think about a function box. If you hike for 1 hour, wouldn't that be 3 miles? Think about it. 1 hour, 3 miles, right? If you do 2 hours, wouldn't that be 6 miles? If you do 3 hours, wouldn't that be 9 miles? Does it make sense? My y values are here, my x values are here. My equation would be y equals 3x. If you take x and you multiply it by 3, you continually get y. So 3 times x is y. All right? So for this, okay, Roger's hiking distance, this is 3 times the hours hiked. There's my equation. Y equals 3x. That's step 1. Now, let me go back. It says, Roger, or I guess in this case you plan on hiking less than 10 hours a day. So we got to think about that for a minute. What's the least amount of hours you could hike? I'm hoping you're coming up with 0. Okay, we can't hike negative hours, so 0's the least, and it says here 10's the most. So my domain, I can only plug in x values from 0 up to 10. My domain is here. My domain in this question is 0 to 10 hours of hiking. And actually, I made a little mistake here. I have to hike less. I should not have put an equal sign there. So actually, I can't even put 10 there. I could put 9.99 hours, but I can't hike 10. I want to hike less than 10. So there's my domain. Okay, those are the only values I can plug in for x, from 0 up to 10. So let's make a table. Since my domain is anything from 0 to 10, I'll plug in 0, and I am going to plug in 10, and I'll show you why in a minute. I can plug in any values from 0 to 10. I'm going to plug in 10 because even though 10's not part of it, that's where my graph will end up stopping. So I can't actually hike 10 hours, but it will stop there. So I actually plugged in 4 points. If I plug in 0 hours, I hike 0 miles. If I plugged in 3 hours, that's 9 miles. 9 hours is 27, 10, 30. Now, we got to think before we graph. Look at my graph paper. Am I going to be able to graph the point 1030 on here? Well, obviously the answer is no, you won't. So I got to pick a scale that's going to work. So I'm going to switch my scale. For y, I'm going to make my scale by 5s. 5, 10, 15, 20, 25, 30, 35, and so on. My x scale is going to stay the same. So my y scale, I'll just make a note of that. Y scale over here is by 5s. And the x scale stayed the same. So I'm graphing. I got 0, 0. 3 right, 9 up would be here. 9 right, 27 up would be here. And for 10, 30, I'm not actually going to put a point. What I'm going to do is this. I'm going to put 1030, and I'm going to put an open circle at 1030, which means the point 1030 isn't part of this, but that's where my graph would stop. So 1030, I can't hike 10 hours, but this would be the point at which this stops. Okay, I got to graph this now. I'm going to go from 0 to 10. You notice how I start at 0, stop at 10. I guess I went a little bit too far on that. Let me just erase a little here on this line. Okay, went a little too far maybe because I had an open circle there. There we go. That's a little better. Okay, so my graph goes from 0 to 10. Can you see my domain? Let me take a red marker and highlight it again. Can you see it on graph paper? My domain goes from here, which is 0, up to here, which is 10. There's my domain. Can you see it on my picture from 0 to 10? Now I want my range. Let me do that in blue. Can you see how the lowest x value is 0? But the highest x value is up to, but not including 30. Can you see my range here? Can you see it here? It starts at 0 and includes 0, but it stops but does not include 30. My range is from 0, including 0, up to 30. Y is between 0 and 30. Can you see that in the picture? That's how we can find the domain and range, because that's one of the things they asked. Identify the domain and range. I just did. The domain is from 0 to 10. The range is from 0 to 30. Of course, when you actually graph this, like on a quiz or test, you wouldn't put this in here. I guess if you did it just to help yourself out, I wouldn't be mad, but we don't really want that in there. That's not part of the graph. I'm just using that to illustrate, just to show you how you can see the domain and range from your graph. Okay, I'm going to stop my video here. I know that was a longer one. I'm not going to do the other worksheet problem. I want to give you guys a chance to try those on your own.